Hi my dear students. So in this lecture we will discuss about the segment tree construction and how it is efficiently solve the range sum problem in big O of log n time. So this is the today lecture. So we will see the before actual construction of the segment tree. So we will discuss the brief primary concepts related to the segment tree, then we will go for the actual construction of the segment tree. So in here segment tree is a binary tree data structure. So what is a binary tree, what is a data structure, I am not discussing here because of this is the prerequisite for this lecture. So segment tree is a binary data structure used to efficiently perform the range queries. So like sum, range minimum, range maximum, etc. So updates also it will done within a log n time. So it support the both range queries and point updates problem. It will be useful in competitive programming and large data set problems, right? So next, so how it is constructed? So start with array size n, size is a n, build the tree in a recursive manner. That means that construct the binary tree in a recursive manner. So each leaf node represent the single element and internal node store the sum of it to children. So what we discussed, it is a binary tree, so that's why it is a sum of it to children only. Time completion of building is big of n. So that means that if it is, this is the root, if it is have this internal nodes and one more children, for example, right? So this internal node is represent the sum of these two elements. For example, here it is a 1, here it is a 2, it will be the 3 is the internal node value. So in this way the segment tree will be constructed. So we will see the what is the range sum. So because of we are discussing this problem, range sum problem we are solving. So that's why we will discuss the first what is the range sum. So first, for example, there is a one array like this 1, 2, 3, 4 and 5, right? So index is 0, 1, 2, 3, 4. So now range sum of 2 to 4. So what is the value 2 to 4? That means that what is the sum of elements from range 2 to 4? 3 plus 4 plus 5. 3 plus 4 7, 7 plus 5 12. So this is the range sum problem. Next one. So next one you see the range sum of 1 to 3. So 1 to 3 means starting from 1 to this is 3. 2 plus 3 5, 2 plus 3 5, 5 plus 4 9. So this is the range sum problem, right? So if you solve this problem in a brute force, that means that what we are solving now, this technique is a brute force technique. So what is the time complexity for this problem solving? Big O of n q. So what is a n? N is a elements, whereas a q is a queries. So how many queries are present? So that is the big O of n into q for solving this problem in a brute force technique. So now question is that there is any better way to solve this problem? Yes, there is a better way. We will see that one, how it is efficiently we are solving. So construct the array in a somehow like 0, 1, 2, 3, 4, like 0, 1, 2, 3, 4. So 1 will be remain same, 3 here, 6 here, 10 here, here it is a 15. You may get doubt how it is came 1, 3, 6 because of you are taking 1, 2, 3, 4 by something, but it how it is came. So 1 plus 2, 3. So 3 I written in this one, 1 plus 2, 3 is the index. So next one is a 3 location. So 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 4, 15. So that means that I constructed array like this, like 1, 3, 6, 10, 15. So this was I written in this one. Okay. So I hope you are clear. Now I want to solve the same problem. A range sum of from L to R is equal to, there will be some formula, that is I am discussing. Range sum of L to R equal to sum of L minus 1 minus sum of R. So this is the formula. Now example, I am going to calculate the range sum of 2 to 4. Because of why I am taking 2 to 4? Because of we are already solved the problem. 2 to 4 is a 12. So now 2 to 4, now what is the sum of L minus 1? So sum of, what is the L? L value is 2, 2 minus 1, 1 minus sum of R value, R value is a 4. So sum of 1 value, what is the 1 value? 3, 3, what is the 4 value? 15. So what is the total? 12. You may get the minus 12 here, but as per according to the mathematics, but that one you took minus negativity, you don't take into the consideration, value is a 12. So what is the time complexity for this one? Earlier we are solving from starting to the till end, that means the searching way from left location to the right index, left index to the right index, but here it is we are not required to search from left index to the right index. Directly we have some formula, sum of L minus 1 minus sum of R. So if you submit this one, you will get the answer, right? So what is the time complexity for this one? It is a big of Q. What is a Q? Q is already discussed, it is a question, right? So now we will see the time complexity for these both two. So that is like for example brute force approach, there is a brute force approach and there is a efficient approach. So efficient approach means just now what we discussed now, that is a efficient approach. That means that how to solve this way, this is the efficient approach. So this is the brute force approach, right? So now, so the problem of, what is the problem? A range problem. So range sum problem, and one more is a, what is the problem? Update. So what is the update? Update means, for example, there is a one array, just now we see that one only, 1, 2, 3, 4, 5. So I will tell you what is the update. For example, if I want to use the brute force approach, for example, this third element I want to update into the 10. So what I can do? Simply I can replace 3 with 10. That's it. It is completed. Whereas the efficient approach, what is the array? Array is like this one, 1, 3, 6, 10, 15. So this is the efficient approach. So I want to add the 3 here. This place, third place is the 3. So it will be remain same, but this need to be updated with plus 10. So it will become to the 16 or something. So here it is a already 3 is there, this value it will become 10. So 1 plus 2, 3, 3 plus 10, 13 will come here. So 13, and this 13 next element will be added, 13 plus 17 will come here. So 17 plus 5, 22. So that means that updation will be continuous from entire array, whereas a brute force approach, it will update in a 1 unit of time. So this is the updates. So what is the time complexity and range query? We already discussed, big of n into q, where is the n is a size, where q is a queries. Update will take only big of 1. So whereas a efficient approach take the big of q, whereas it is taking the big of n, right? So that means that if update is very less, we can go for the brute force approach, because of it is taking the one amount of time, right? So I hope you understand the update, how it is doing efficient with respect to the efficient approach. So right, so now we'll see the actual construction of the segment tree. So now it is a actual construction of segment tree is starting. So I am taking one example, so that you can see here. So 1, 2, 5, 7, 1, 2, 5, you take this is 6, 6, 7, 9. So what we discussed, so by segment tree is a binary tree. So in that case what we have to do, divide the array into the two parts. So that one you divide the 5 this place into the two parts. So that you take the 1, 2, 5, here you construct the 6, 7, 9, right? Again you divide this into the two parts. One is a 5, here it is a 1, 2, right? So here you divide array again 9, 6, 7. So again you divide this into the 1 and 2, because of we are dividing the array into the single elements. So till the point we are dividing, right? So now you are divide the array into the two parts, right? So till the single manageable unit. So now segment tree, how it is constructed na? So here it is a, what is the value? 0. So what is the value element in the root? 1. So 1 will be propagated here, 2 will be propagated here, so 3 will be stored in the root node. So here it is a 5 is there, so 5 will be propagated here. So 3 plus 5, 8 will be stored here. Similarly 6 will be propagated upon 6 and 7, so 6, 7 plus 13. Next 9 will be go to the up. Next 13 plus 9, 22, 22 and 22 will be go to the root node. So it will be 22 plus 80, 30 will be stored in a segment. So this is the way to construct the segment tree, right? So now I will write the clear manner how it is a segment tree. So now you see 30, right? So in a 30 there will be two categories. So that is a 8, here it is a 22, next 3, here it is a 5, here it is a 1, here it is a 2, here 13, 9, 6, 7. I am not writing anything extra, just try to understand. So what is the values is coming, just I am writing 1, 2 will be remain same, 3 will be remain same, 3 will be, you can see here 1, 2, 3 I am writing, right? So 5 is there, 5 I am writing, 5 plus 3, 8 I am writing. So 8 I am written here. Similarly I constructed the entire tree. Okay. So now it is a full binary tree. So it is a full binary tree. So why you are calling it is a full binary tree? If it is internal node is having 2 or 0 children, so then we can say it is a full binary tree. So now you can see what is the internal node. This is the internal node, this is the internal node, this is the internal node, or this is also internal node, this is also internal node, this is also internal node, right? So internal node should have 2 children or 0 children, then we can say it is a full binary tree. So now you can check it. These are the 2 children. So this also having 2 children, and this internal node have also 2 children. This is having 0. So as per our definition, it is a 0. So here also 2, here also 0. So as per our definition, it is a correct. So it is a full binary tree. So now we will see the implementation of the segmentation tree. That means that how these array values, how this segment tree is stored into the array. So naturally, if you are seen in a programmatic part, it won't be like this kind of structure. It will be stored in array. So that's why. So how it is stored in a array, we will see this one, right? So that means that you can see here left child equal to 2 into I plus 1. So next one is a right child equal to 2 into I plus 2. Parent equal to I minus 1 divided by floor. Okay, floor. So this is the formula for constructing the tree, right? So now we will go for the previous one. So now you can see what is the value storing here. This is the 0, 1, right? 2, 3, 4, 5, 6, 7, 8, 9, 10 will left, 11, 12. Right. So why it is 9, 10 will left? Because of here it is a 2 children should be there, but it is not there in our problem. So that's why we are leaving that is a empty. So now we will see the array construction for this tree, right? So that is like first one is a 38. So I am not writing nothing else new here. So 30 I am writing copy, 8 I am copying next, 22 I am copying, next 3 I write, 5 I write. So next 13 I write, 9 I write, next 1 I write, 2 write, 2 dummy nodes because of it do not have any children. So that's why it is dummy node, next 6, 7 again dummy. So that's what I am writing here. 38, 22, 22, next 22, 3, 5, 13, 9, 1, 2, D, again D, next 6, 7, 3 D's will come, D, D, D. So starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So now you can check it here. So what is the dummy node? 9, 10. So here it is a 7, 8 is there, 9, 10 is the dummy nodes. So that means that there is no children. Here it is a 11, 12 is a children, but 13, 14 it is nothing is there. So that's what I written here. Okay. So now we will solve the range sum query. How it is solving the range sum query in a log n time. Okay. So now I am taking one problem. So that is taking one example, that is 1, 2, 5, 6, 7, 9. Previous problem I am not taking anything extra. So just try to construct the tree, right? Construct the tree. So that is like here it is a 1, 2, 5 will come. Here it is a 6, 7, 9. Here it is a again 1, 2, 1, 2. Why I am writing? Try to understand here. So I think it is already there, right? So no need to write again. So directly I will write the segment tree so that you will get clear idea, right? So I'll write segment 3, that is 30, that is like 30, and 30 will be divided into 2 parts, that is 8, 22, next 3, 1, 2, here it is a 5, here is 2 parts, so that is a 13, here it is a 9, here it is a 6 and 7. So here it is a 0 to 5. So that means the range index is stored from 0 to 5. So here it is a 0 to 2, here it is a 3 to 5, here it is a 0 to 1. What is the value? 1 here. So here it is a 1 to 1, here it is a 2 to 2, here also 2 to 2, here it is a 3 to 3, here it is a 4 to 4. So now here it is a 3 to 4, here it is a 9, 5 to 5. So what is a 0 to 5 means? Here it is a range value, range sum value from 0 to 0 index to 5th index. What is the value? 30. So you can check it here. You can check in a previous value. So what we see in that one? Here it is a 30, right? So index starting from end to the, it is a 30. So that is the value I written here, right? So next is a 0 to 2. 0 to 2, what is the value? Or else I can write here. Just wait a minute. 1, 2, 5, 6, 7, 9. So what is 1 plus 2? 0, 1, 2, 1, 2, 3, 4, 5. So sum of this 1 plus 2, 3, 3 plus 5, 8, 8 plus all this sum you will get 30. So that is the ratio here. 0 to 5 range value is 30 here, right? So similarly all these values which is written. So it is range says 8 value says that 0 to 2 is a 8. So 3 is saying from 0 to 1 and 1 is saying range starting from 1 to 1. 2 is saying range starting 2 to 2. So it means that 2 you can see here it is example. Range is starting index is 2, ending index 2. What is the range sum? It is a 2. What is here also? 2. So here also 5 to 5. So here 5th index, it is saying 5 to 5. So that means that it is a index is saying what is the range value which represent the what is the this index. So simple I can say this index is saying 0 to 5, this value is indicating what is the range sum of 0 to the left to the right. What is the value? That value will be present in a 30, 22 or 13, 19, everything will be like this. So now what I want to calculate the sum of range sum of 2 to 4. So there will be 3 condition for checking this one, that is a total overlap, and second one no overlap, third condition partial overlap for checking. So what is our query? Range of 2 to 4, right? So we go to the here. What is our query? 0 to 2 to 4. 2 to 4 we want to calculate the range. So now we go to here. So 0 to 2 compare with our query is 2 to 4, right? So 2 to 4 you compare with the 0 to 5. So now 0 to 5 you write here, compare. So whether it is a partially overlap or fully overlap, partially overlap, because of 0 to 5 is a complete, this query which is given, it is a part of it, it is not completely. So it is a part of it. So in that case, so that is a partial overlap. No overlap means no question will come. Total overlap means complete overlap. So if it is here, it is a partial overlap. If it is partial overlap, call the left query and right subtree. Now you check it, 0 to 2. So 0 to 2 is there, but here it is a 2 to 4. Again partial overlap, call left right. So here it is a 0 to 1. So 0 to 1, there is no overlap, right? So 0 to 2, there is no overlap, return 0, right? Here it is a 2 to 2, it is also partial overlap, return 5, return 5. So here it is, if it is partial overlap, call it. If it is no overlap, return 0, like that. Here it is a no overlap, no need to check the condition, what is the value stored into the children's. Because of it is no overlap, just ignore it, send it to 0. Here it is a 2 to 2, so it is a partial overlap. 2 to 4 means partial overlap, so send the 5 here. So it is a, what is the value? 0 plus here this side will come 0, here it is a 5. So 5 will come here. Next come to the this side, because of we divide two parts that time, na? 0 to 5 and 2 to 4. So compare with this one, 3 to 5 and 2 to 4. So it is a partial overlap, you come this side. So again there will be left and right two sides, you can check 3 to 4. 3 to 4 is again partial overlap, you come here. So here it is 3 to 3, so it is a partial overlap, you call 6 here, right. So 3 to 4, it is a partial overlap, right. Compare with 3 to 4 and 2 to 4. So it is a partial overlap, you send the 7. So 6 plus 7, 13. 13 will be sent here, right. So here it is a 9, 5 to 5, there is no overlap, send the 0. So 13 plus this side 5. 13 plus this side, what is the value? 5. 13 plus value 5, that is the 18 is the value. So check it, 2 to 4, what is the value? 2 plus 5, 7, 7 plus 6, 13, 13 plus 7, 20 is coming. I just hold a minute, I did some mistake somewhere else. 2 to 4, 1, 2, 5, 6, 7, 9, 2 to 4, 5, 6, 11, 11 plus 7, 8, correct, right, sorry, 2 to 4, this is a 5, 5 plus 6, 11, 11 plus 7, 18, so 18 is a sum. So this is a about total value. Okay, I hope you understand. So that means that every time it is dividing the two sides. So again this one divide, again this one divide, again this is divide, like this it is keep on going. So in that case, that means that the problem will be divided into the two parts, again problem will be divided into the two parts, like that it will be getting the range sum value. So range sum value, so that's why time complexity is a big O of log n, big O of log n. So this is the time complexity, right. So I hope you understand. So I want to give small recapitulation, like, so regarding overlap and total overlap, partial overlap. For example, our problem is 2 to 4. For example, range is 2 to 5. So that means that 0, 1, 2, 3, 4, 5. So this value is stored in this one. So what I need? 2 to 4. So it is a partial overlap, right. So no overlap means, for example, this you take 0 to 5 is there, na? So your range is 1 to 2 to 4, but when you are searching, that is 0 to 1. So that means that there is no match, there is no partial match, there is nothing is match. So in that case it is a no overlap. So total overlap means your range is 2 to 4 you want, and question is 2 to 4, and you are searching at 2 to 4. So then it is a total overlap. So this is the three cases we have to check it for: total overlap, partial overlap, and no overlap. These are the three conditions we have to check it. So if you have any queries, you can ping into the comments box. So thank you for watching. I hope you enjoy the session and you learn something. If you like, if you learn something, please press the thumbs up symbol and share to your friends. Thank you for watching.